the largest study to date of Africans. We had over 3,000 Africans in our study from about 120 ethnic groups. We also looked at 98 African Americans from 4 regions in the U.S., and then we had a large comparative data set from outside of Africa, roughly 1,500 people. This is showing the distribution of the populations that we studied in Africa, mainly places where we've done field work, but although it's pretty comprehensive, we're missing data from a number of regions, like North Africa in particular, Central Africa, and Southern Africa. The first result I want to show you is a measurement of genetic variability, just overall genetic diversity, and the height of the bar indicates how much diversity there is. So higher the bar, more diversity. And in orange are the sub-Saharan African populations, who are consistently the most genetically diverse compared to all other populations. In blue, we have European and Middle Eastern populations, red Southern Indian, pink East Asian, green Oceanic, and purple American Indian. So you see this decrease in diversity as you move west to east across Eurasia, and consistent with this pattern I showed you of a history of migration events across that region. Small detail for you to see any of the details here. I just want to show you the general picture. From all that genetic data, we could estimate genetic distances or similarities between pairs of populations. And then we can construct a phylogenetic tree. So populations that are genetically more similar are going to cluster near each other in that tree. And what we found is that populations generally cluster by major geographic regions. So here are all the Indian populations, Central Asian, European, Middle Eastern, East Asian, American, Oceanic. Here we have North Africa. And even within Africa, they clustered by geographic region. East Africa, West Central Africa, and Southern Africa. Now there's one exception here. In green, or actually they're not in green, they're in yellow here, are the pygmy populations from Central Africa who cluster with those Bushmen, the Kungsan from Southern Africa. And I'll get back in a moment. This is another type of analysis we did. It's called principal components analysis. And now we're moving away from populations and we're looking at individual ancestry. So each one of these circles represents a person, and if they're genetically very similar to another person, they're going to cluster together. And we can see differentiated, here are all the African individuals, here are non-Africans. Then we can distinguish American Indians, Eurasians, Oceanic populations, and here we have that Hadza group of hunter-gatherers that speak with a click in Tanzania, very distinct on a global level. If we do the same thing within Africa, all of these outlying groups are hunter-gatherers. And they're probably differentiated because they've had a long history of being very small population sizes, and very differentiated. They've had time to differentiate. Interestingly, within in the other populations, we see they cluster by geographic region again. So Northern Africans, Eastern Africans, Western, Central, and Southern Africans. Now this is another type of analysis to try to look at individual ancestry. Each of these, you can't see it, but they're composed of lines, and each line is a person. And each color represents an inferred ancestral population. People can have multiple colors, indicating that they have mixed ancestry from different regions. So down here we have the non-African populations, or individuals, and we can see that most individuals cluster by major geographic regions. So in blue are Europeans, Middle Easterners, Southern Indians, we have East Asians, Oceanic, and American Indian populations. People from Central Asia show mixed ancestry from East Asia and probably Middle East or Europe. But what I want you to note is all the different colors here in Africa. So that's indicating a huge amount of genetic diversity comparable to what you see on the entire globe. And I'll just point out a couple of trends. In orange, these are the Niger Kordofanian speaking populations I told you about that originated from West Africa. And they were surprisingly homogeneous. We actually didn't see a lot of variation amongst them, probably reflecting that recent spread from a common ancestor. In purple, we have the East African Afro-Asiatic speakers. In red, Nilo-Saharan speakers like the Maasai, who interestingly we can trace to a homeland in southern Sudan, consistent with archaeological data. One surprise, here we have populations from the region around Lake Chad who speak a language classified as Afro-Asiatic, but genetically, they didn't look anything like the Afroasiatic speakers. They looked like Nilo-Saharan speakers, so suggesting a possible language switch at some point in the past, and that was something that wasn't known before the study. Other things we can see are here the hunter-gatherers, the Hadza, the Sandawe. Pygmies are shown in dark green, and the San Bushmen from southern Africa in light green. And one of the surprises is that one of the most eastern pygmy groups seem to show common ancestry with those San populations. So we've done a similar analysis in Africa, and to simplify it, I've just grouped together individuals from certain geographic regions. And again, we can see that the pattern is, in orange are these Niger-Kordofanian speaking populations, and we can see reflections of this migration to West Africa and then down south, and another migration into southern Africa. We see a lot of diversity even within small geographic regions. And again, interestingly, here are the San in this bright green, here are the pygmies of Central Africa, and there appears to be shared common ancestry. So that raises an interesting question. We have 4 of the most traditional hunting-gathering populations remaining in Africa. They show evidence for common ancestry. Other studies that we've done suggest that ancestry probably was predated at least 30,000 years ago, may have been closer to 50,000 years ago, and then they diverged. I now want to tell you about 2 of the most admixed populations on a global level. The first one is the so-called self-identified Cape-colored population from Cape Town in South Africa. And what we see when we compare them to populations from around the world, we see almost equal ancestry from the San, Bushmen, South India, East Asia, Europeans, and Bantu speakers. They are the most admixed that we see in the whole world, and it's reflecting the unique history of this population in Africa. There are African Americans, and what we see, as expected based on the history of the slave trade, predominantly this West African Niger-Kordofanian ancestry, but a lot of variability mainly in the amount of European ancestry, which ranges from 0 to greater than 50%, but on average it's around 17%. We did another study, slightly different, where we pre-assigned, we said, let's assume these are the ancestral populations around the world, and now let's infer ancestry in the African Americans. And the main point I want to make is that African Americans, every individual we looked at, seemed to have ancestry from 2 different regions of Western Africa. So suggesting that if we were to try to look at ancestry, there's a lot of ancestry testing being done, it's going to be very hard to trace back to a particular ethnic group, because I predict that most people will trace back to multiple regions.